is Professor Brian Broderick, and I'm the Global Director of the School of Engineering in Trinity College Dublin. Good, so what I want to talk to you today about is about studying in Trinity College Dublin, and in particular studying engineering in Trinity College Dublin. I hope that all of you will find what I have to say interesting. So looking at this slide here, it gives some facts about our university. You can see there the date, 1592. We're a very old university, over 400 years old, and we're ranked as the top university in Ireland, and we're approximately ranked 100th in the world. So we're a high-ranking university, probably ranked in the top 20 in Europe as well. And we have some very high rankings in some areas like entrepreneurship and startups. So we're very much a university that's connected in with the idea of industry and giving people a chance to start their own businesses. Ireland is a very good place to study. It's a very safe location. You can see it's ranked as one of the safest locations in the world to study in. We have a very nice campus which is located right in the very centre of Dublin city. So Dublin is the capital of Ireland, has a population of about 1.5 million people. So not a very big city by global terms, but quite a big city by European terms. And our campus is located in the very centre of Dublin. So all around the campus we have shops and theatres and restaurants and cafes and other social and cultural locations that you can enjoy. And this is a view of our campus itself. So we're a historical campus. We're founded around the same time as Oxford University and Cambridge University that everyone will know about in England. So in fact, we are Trinity College Dublin, and there is also a Trinity College in Cambridge and a Trinity College in Oxford. So our university is very similar to Oxford and Cambridge in its appearance and its layout. Some of our oldest buildings are very fine architectural buildings, and we have lots of tourists come in as well as students to see them. In particular, there's our old library, which dates from the 18th century. But in the engineering school, we're more interested in modern things. So we've established a science gallery, which shows exhibitions on themes related to scientific research. And most students, and indeed the general public, find those very interesting. If you want to apply to come to study in Trinity College Dublin, if you're applying from outside the European Union, then you can see the link on which you need to apply and the details of that you need to supply. There's an application fee of €55, but the application procedure is quite standard, and we really pride ourselves in getting back to applicants as quickly as possible and giving them a quick decision on whether or not they can be offered a place on our course or possibly a provisional place based on their exam results that they are to get in the future. Coronavirus is with us, as it is everywhere in the world. You will be interested to hear and happy to hear that the Irish government has been very proactive in reducing the spread of the coronavirus, COVID-19, throughout Ireland. And we expect all universities and schools to start again in the next academic year in September on schedule without any delays. In the meantime, as we're coming to the end of this academic year, all our lectures and our assessments and examinations are continuing online. So students' education is continuing. If you do apply and you have to find out more information about that, there are a couple of links there that you can apply to. And again, our applications team are very interested in helping people with those kind of queries. We have lots of student support services at Trinity College Dublin, from counselling, health services, equality, and there's a multi-faith room for people who are interested in practicing their religion. There's support from the Students' Union, and there's special supports from what we call our global office for international students to help them to settle into their life in Ireland and in Dublin. Okay. So moving on from those general aspects to think more about education that students receive at Trinity College Dublin, these are what we describe as the Trinity graduate attributes. So these are really our characteristics that our university wants everybody who graduates from Trinity College to have. And they're grouped under a number of different headings that you can read there. And they're all very sensible and very important attributes for somebody to have when they're thinking about moving into the world of work and moving into their life generally. So one is to be able to act responsibly, another is to think independently, another is to develop continuously, and another is to be able to communicate effectively. So all students, no matter what field they're studying in, whether it's engineering or medicine or law or science, or arts or the humanities, they will all have these very general characteristics. But the way in which we go about achieving those characteristics, these attributes, is different from course to course. So students develop these, engineering students develop these attributes in one way, arts and humanities or business students or medicine students will develop the attributes in a different way. And this is what that's all about. This is about when you finish your course, most students are very interested in what happens to them afterwards, and you can see that for engineering students, nearly all of them go straight into industry employment. So everyone who graduates from engineering at Trinity College Dublin will receive multiple offers of jobs, both in Ireland, elsewhere in Europe, and in fact anywhere around the world that they like to apply. It's a very well-regarded degree, and lots of employers are very keen to recruit students who have our degree, finished our engineering course. Some students, of course, go on to further study, whether that's a specialised master's course or a PhD course, or maybe even to change stream slightly and go into a different field. And some others are just do different things like gap years or whatever. But by and large, most students end up going directly into industry, and they find that they have many job opportunities made available to them. This is what our engineering program looks like and how it is structured. We have one program that runs for either 4 years or 5 years. If you do 4 years, then you will graduate with a bachelor's degree, what we call a BAI degree. BAI is Latin for Bachelor of the Art of Engineering. And then if you continue on for another year, so complete 5 years in total studying engineering at Trinity, you will graduate with a master's degree. And that's what we call our MAI degree, Masters in the Art of Engineering. Irrespective of where you finish, whether after 4 years or 5 years, all students on our engineering program start in a common class for 2 years. In other words, all students enter into one big engineering class and they study together for 2 years. And after those 2 years, then they select which stream to go into, whether that's biomedical engineering, civil engineering, mechanical engineering, computer engineering, all the different options that are listed there. So this is quite an unusual feature of our course. Most engineering courses worldwide, either you enter directly into your stream of engineering that you want to study, mechanical engineering, computer engineering, whatever it is, or possibly you will have one common year and then choose to specialize. So to have 2 common years and to specialize at the end of that time is quite unusual. But we find that most employers are really happy with that idea. Nowadays, engineers are expected to know a lot about a lot of different things. The range of information and knowledge and skills and the engineering tools that they need to have is very broad. And the only way to develop that breadth of ability and to be a really good engineer afterwards is to have a solid base and a solid foundation. So we take 2 years to build that foundation, and you'll see the subjects that you study in those 2 years in a minute. And then after that, the students spend either 2 years, year 3 and year 4, or possibly 3 years with year 5 as well, to develop in their own specialist field. In year 4, we have a variety of options available to students. They can either just take normal courses and complete a capstone project, so that's a large independent individual project that students do, and then graduate. Or they can choose to split their year and have a semester in Trinity and take an internship for a year. So that will be an paid internship in an engineering company, either in Dublin mostly, but it could also be anywhere around the world. We have students on internship in engineering companies all throughout Europe, and indeed some are even in the US and in China. And it's possible as well to go on an international exchange. So for year 4, you can choose to leave Trinity completely and study that whole year in a different European or indeed global university. So if we look just without spending too much time on the details, because that would take too long, but we can look at the type of subjects that you can expect to study when you come into Trinity College. So in year 1, these are the different courses, or we say modules, that the students study. And you can see that in year 1, there are 2 types of modules listed there. One type is basic mathematics and science. So we have mathematics courses, physics courses, chemistry courses. And then there are some applied scientific courses. So science applied to engineering. And that would be the case of electrical engineering, mechanics, etc. There's also a course in computer engineering where you do lots of coding and learn about other aspects about IT. And the students all engage in project work as well, design projects. That's an essential characteristic of our course in Trinity, which is different to many courses worldwide, but it's quite similar in a way to many American universities, in that we believe that it's really important that students are applying the new knowledge that they gain in their courses, in their modules, that they apply those immediately in project work. So we have an engineering design project 1, engineering design project 2 listed there. In second year, the courses change slightly in their nature, because we now are learning less about fundamental sciences and we learn more about the application of sciences, again, to different areas of engineering. So we learn about solids and structures, which will be important if you want to go on to work as a structural engineer or a mechanical engineer, or who's going to be designing aeroplanes or wind turbine blades or new buildings or new bridges. And there's other courses to do with thermal fluids, which gives you the basics that you'll need if you want to work in the energy sector, and electronics, which gives you the basis if you want to work in the IT or the electronic manufacturing industry. In year 3 then is when you choose which of these specializations you want to go into. So there are still some common modules, and you'll see listed at the top as well, there's something called Trinity Elective. So this is a relatively new initiative that we have in our university. In Trinity College, all students are given the opportunity to pick from a very wide range of subjects outside of their own course of study. So for engineering students, they're allowed to choose from a list of subjects which are not necessarily just engineering. And the idea is that the students get a much broader education and they get a little glimpse at what other people in the university are studying. So you could study English literature, you could study advanced mathematics, you could study some more aspects of computer programming, you could study some aspects of medicine, whatever you like. So there are opportunities on 2 or 3 occasions throughout the course to study that. Just coming back to the specializations then, these are the 6 different specializations that are listed. Biomedical engineering, which is a very popular one and it's quite unusual. Not all engineering colleges offer that. There's civil, structural, and environmental engineering, that's my own field. There's computer engineering, electronic engineering, and a very popular joint course that covers both electronic and computer engineering. A lot of students are attracted to that for obvious reasons. And then there's a separate program in mechanical and manufacturing engineering. So all that I've been talking about so far has related to what we call our standard engineering program, and there are about 250 students per year taken into that engineering program. This is a slightly different program that we have called Engineering with Management. It's a more specialized program and it only has 30 students per year in it. In this case, there's direct entry into that program in first year, so you spend 4 years studying, or 5 years, studying engineering with management. And About in the engineering and management course, roughly 2/3 of the subjects that you will study will be the same as on the regular engineering program, and 1/3 will be slightly different. So the idea of the engineering and management course is that it sets students up to move more quickly into careers in management within the engineering sector. It's geared mainly at the manufacturing sector. So you can imagine in a manufacturing facility, there's a lot of management work to be done. And most engineers find that after they graduate, that they spend 5 or 10 years working as a technical person. But after that time, that they move pretty soon into management responsibilities. They start to think about finance, they start to think about supervising other engineers that are working with them, planning work schedules, looking for contracts, planning the future, etc. So some students, some prospective engineering students are really attracted about that, are really attracted to that side of the career. And if you are attracted to that side of the career, then this engineering management course is a really nice hybrid option for you, because it allows you to become an engineer, the same as anyone else, but it fast tracks you into that career in management later on. So a really important aspect of our program is that at the end of, in the last year of study, whether it's year 4 or year 5, depending on what you choose, everybody gets to do a large project. And because we are a research university, very much driven by our own research interests and our own research fields, that project in Trinity College is nearly always a research project. So it allows the students at the end of their study to engage closely with an academic who is a leading research expert in their field, and to work with other students, master's students and PhD students, very often in a research team, all trying to tackle a research project together. So the next few slides that I have here just give an idea to you of the different fields in which that research and those research projects take place. So in Civil, Structural and Environmental Engineering department, and there's a lot of work into energy, but especially into renewable and sustainable energy, like wind energy and wave energy. There's a big emphasis in looking into the environment and protecting the environment. And then there's a lot of projects related to geotechnics. How do we design, make use of the ground in the way that we should do as engineers? And in structures, so that's the design, construction of buildings and bridges. And then also transport, and especially public transport and modern forms of sustainable transport. In mechanical engineering, these pictures give an idea of the spread of research activity that's there. In the top left, you can see bioengineering. In bioengineering, you start to look at aspects of engineering that relates to the human body, to health and to medicine. So it can involve maybe designing a new implant for a hip in the body, or it could involve developing some new sensor that you can use to monitor what's happening in a person's brain as they're thinking. And both of those are obviously designed to help people working in the medical environment. There's also in mechanical engineering, a big area that looks at energy, especially renewable energy as well, but also more traditional forms of energy as well based on combustion. There's a big field related to fluids, acoustics and vibration, and a lot of their work is in the aerospace sector. So when you're in a plane, you can hear the hum of the plane and the rattle of the plane. What should engineers be doing to reduce that from happening? Forensic engineering is looking at when things go wrong, when things break, when things fracture, and trying to figure out what it was that caused that to happen. And there are some other areas there I won't go on at length, except to note this field here at the bottom here is robotics. And there's a colleague of mine working in mechanical engineering, and he has developed a robot for use in the healthcare sector. So as a sort of a robotic nurse, if you like. And that featured very recently on Time magazine, that robot had him on the cover of Time magazine. So our research is getting noticed worldwide. In electronic and electrical engineering, these are some of the projects that are taking place there, or the research areas. You can see bioengineering there as well. a lot of our work in that department relates to the use of media, the digital media, either for music or for communications or for video. One of my colleagues, for instance, was worked on the production of video for movies. And in fact, he won a technical Academy Award, a technical Oscar a few years back for his work in that field. And as well as that area, another large area for the electronic engineering department is networks and communications. So how do we design, how do we build more modern networks and communication systems to transfer data around the world, and maybe to get the sound working on a webinar more quickly as well. Okay, so in computer engineering, then the sort of fourth of the four fields that I can look at, you can see the different areas that are there. So obviously, when you are working as a computer engineer, you have to learn how to code and how to develop projects and software and technologies, IT, information technology. But that's kind of the fundamental work that you get to do. So it's kind of understood that if you're studying computer engineering, that you will develop those skills. So we like to think more about what happens with those skills. What do you use those skills for? And these are some of the different application areas. So one large application area that we're looking at is future cities. All the information that's flowing around the city, to controlling traffic, controlling buildings, related to people, the data that's on their phones. What use can be made of that information to make our cities better and safer places to work in? What forms of artificial intelligence can we use and can we develop based on all those data streams to allow us to manage life and to manage devices even more effectively? So all of these projects here, whether they're computer engineering or going back electronic engineering, mechanical engineering, civil engineering, I'm showing you those because the idea is that when you finish your course in year 4 or year 5, you will be developed enough as an engineer to be able to work on that properly, to work in any of those projects. This is the last thing I want to mention. A big initiative in our university is creating something that we call E3, and this is bringing together engineering, environment, and emerging technologies. So it's bringing together different parts of our university to develop new research streams, but also new teaching programs, new courses, new modules, new projects for students that will address the whole area of sustainability, and to try and figure out what it is that students should be learning today so that they can be working to the very best of their ability and potential in the future to do things differently, to do things in a more sustainable way, and so that we can continue to grow and develop as a society all around the world without damaging our environment too much. So we have a very big initiative around that, and we're just started construction on a large new teaching building, and this E3 building will house most of the classes for engineering students in the future when it's built in approximately 12 months' time. So if you come to study engineering at Trinity, you can expect to be studying in a brand new building with new laboratories and new classrooms and all the best teaching facilities in this new E3 building. Okay. I'll just mention quickly, I won't go through it at length, and we have scholarship opportunities for non-EU students, and €5,000 per year for 4 years for undergraduate students. Anyone who's accepted onto a place in Trinity College will be eligible to apply for one of these, and the application process is relatively straightforward. So you can submit that application for the scholarship at the same time as when you submit your application for a place on the course. Thank you all for attending, and anyone who is interested in finding out more about Trinity College, about engineering at Trinity College, and applying for it, or if you have questions about our course or our program, there is an email address there that you can send an email to, and we'll get back to you as soon as we can. Okay, so thank you everybody, all the best, and I hope some of you will come to Trinity to study engineering. Okay, bye.